kindly refer it when you want. Okay, so we'll start wherever we have stopped in the last session. So in the previous class, we were discussing regarding the different types of water demand. What is water demand? What are the different types of water demand? We have overviewed what is the domestic water demand and what is an industrial water demand. We have seen what is domestic water demand and we have seen what is an industrial water demand. Now, in this class, we will be seeing what are institutional and commercial demand. Okay, what are the different institutional and commercial demand that we are going to see. Now, as we know that institutes means all these are nothing but here in the residential areas or in the residential building, say only 4 people, 8 people, 10 people, right, might be residing, right? But in an institute, if we consider the institute, right, we are having the schools, offices, jails, say, and then in the commercial areas, we will be having hotel, motel, right, and then in again railways, bus stations, right. All these, you know that these will be having many people will be there in these particular buildings. Okay, many people will be there in these particular buildings. So again, the water requirement in these particular building will be high, because as the many people will be there, right, many people will be using the facilities over there in those particular buildings or establishments. They will be using the water. So in when public is there in a huge number, then we require a good quantity of water in such kind of establishments, right, and we need to fulfill their requirement in these particular say establishments. So institutes is going to cover all the offices, school, colleges, whereas your commercial area is going to cover your hotel, then cinema, theater, railway station, bus station. All these will be considered as the commercial establishments. Okay, now the water required in these particular type of buildings is going to be defined as below. Okay, it is going to be shown as this particular the table. Okay, it is, we are in these tables, right, we are going to have the three columns. First is serial number, type of building and construction, per capita requirement. Okay, per capita requirement. So here first we'll see the factories where bathrooms are required to be provided. So we require 45 liter per person per day. And then hospitals, right, number of beds not exceeding 300 numbers, it is 340 liters per person per day. Okay, per capita per day. The number of beds exceeding 100 number, 450 per capita per day. Okay, then the nurses with medical quarters, it is 135, hostels 135, offices 45, restaurants 70 liter per LPCD. I call this per capita requirement, it is liter per capita demand. So I, in a short form, I will be using LPCD. Okay, so restaurant 70 LPCD, hotel with bed, that is with the lodging, we are going to consider 180. Cinema hall, we are going to consider 15 per seat. Water requirement is 15 liters per seat. And then schools 45, boarding schools 135. Garden, it is 35 per square meter, and then 35 liters per square meter. And then animal vehicles, we consider it as the 45 liters per animal per day or per vehicle per day we are going to consider. So here what you can see that the factories, your offices, right, our house, how much quantity we are going to convert, we require 135 liter in the normal houses. But whereas here restaurants and hotel, right, or some of the restaurants, say here we are having the less requirement, here offices we are going to have the less requirement. Why such a less requirement is there is because here only you are going to drink water, or might be you are going to the urinals, right, but you are not going to have the washing kind of a things, cooking, then washing of a utensil. All these activities you are not going to perform over here. So that is the reason why some of the figures are less. But whereas some of the figures are again reaching 135, again your restaurants, right, hotel, it is 180. Because see, when we are going to in the restaurants with having the lodging, again cleaning of that particular lodge or cleaning of that particular hotel, along with the washing of the utensil basins, washing of the utensil, again bathing, washing of the clothes, including all, per person per capita, it will be coming up to 180 lpcd. So again, when cinema halls, hardly we are going for the urinals, so it is going to be 15 liters. Schools, it is coming as 45. The reason is you are going to for the drink and the urinals sometimes, and this is how the amount of water requirement into the commercial establishments or in the institutes, it is going to vary. Okay. Next is demand for public use. Okay. Now, when we call the demand for public use, here we are going to consider the cleaning of sewers, right? Here, washing and sprinkling of roads, cleaning of sewers, your watering of public parks, garden, right? Fountains, right? All these will be coming into this particular category, that is the demand for public use, right? Here, the demand of public use, again, we are also going to consider the public latrines or public your WCs we are going to consider. So here, all these, whatever the establishments are there for the commercial, say for the public usage, that will be considered under the demand for the public use. Okay. Here, again, one more thing, the provision of 5% of the total consumption is made in designing the water work of the city. Then in the public park, right, the water requirement is being divided into the three the required water and water requirements. Public parks, we require around 1.4 liters per meter square per day. We want, if you want to sprinkle it, if you want to watering for the plants and all, if you want to have, so 1.4 liters square meter liters per meter square per day. And then street washing, we require around 1 to 1.5 liters per meter square per day. Then if we want to have the sewer cleaning, we require around 4.5 liters per capita per day. We want the water. Next is, we will be having this fire demand. Here in this fire demand, where we may also get some problem for the problems in the examination. Okay, we may get some problems in the examination in order to as a question. So here in the fire demand, now as I have told, we require some quantity of water, right, in order to fight against the unexpected the fire or unexpected the fire outbreak. Okay. Now, if we want to have this amount of water required for the fire demand or in order to extinguish fire, right, we require a huge quantity of water, because we don't know how much will be the intensity of that particular fire. The larger the intensity, larger the quantity of water that may be required in order to fight against such kind of an fire accidents. So the extinguishers, you already know that it is going to have the fire hoses, right? It is going to have the fire your firefighting vehicle will be having the tank filled with water and all, and again the water hoses we call it as. So it requires a huge quantity of pressure, say around 1 to 2 kg per centimeter square of pressure is going to be required, and moderate fire, we require around 1100 liters per minute of water we require in case of modern fire accidents. Okay, and it requires a huge and suppose if the fire is having a strong fire, then we require around 3 to 5 hours of water has to be circulated for such kind of a fire outbreaks. So here what happens is we require a huge quantity of water when we want to fight against the such kind of fire accidents. Okay. So here we require, in order to find out the quantity of water required in order to fight against such kind of the fire accidents, we are going to find out the quantity of water required in such kind of a fire accident. For that, we are going to develop some of the formulas, that is, in order to find out the quantity of water required in case of fire accident in liter per minute. Okay, so here, first formula that we are going to use is Kuchling's formula. Okay, we are going to utilize this particular formula called as a Kuchling's formula in order to find out the quantity of water we required is 3182 square root P, where Q is nothing but the quantity of water required in order to fight against the fire accident in liters per minute. Okay, in liters per minute. Q is nothing but the quantity of water required in order to fight against the fire accidents in liter per minute. Okay, in liter per minute. So we, in order to find out that quantity, we will be utilizing this particular formula. This is very, very, very important as examinations are concerned. This particular problems may be asked from this. So Q is equal to 3182 square root P, where Q is equal to the quantity of water in liters per minute, and P is nothing but the population of that particular town. Okay, population of town or city in thousands. So this is what the Kuchling's formula is going to be. This, you have a note of this. It is going to be required in order to solve the problem. Then next formula we will be utilizing is Buston's formula. Okay, next formula we will be utilizing is Buston's formula in order to calculate the quantity of water required in case of fire accidents. So Q is equal to 5663 square root P. Again, Q is nothing but quantity of water is required in case of in liters per minute in order to find against the fire accidents. Okay, and P is nothing but again it is population of a city in thousands. See, one thing you need to remember is population in thousand. If they give you 1,40,000, so you should represent it as how many? How much? How much? Yes. If they give you the problem in a problem 1,40,000, now in thousands if you convert, yes, any reply? Are you getting the point? Amrut?
So 140,000.
140,000. So P in 1,000 means 1,40,000. P in 1,000 means P value how much you are going to take?
140. 140,
yes.
sir.
Yes, we are going to take 140. So this thing you need to remember. See, population. Suppose 2 lakh population I have given in the problem. So you will take, if you divided 2 lakh, if you divided 2 lakh, right? If you divided 2 lakh, how much will be your population in 1,000? Yes?
200. 200.
2 lakh. I am using this paint. Probably my handwriting won't be correct in this because I'm using the paint. So I should divide it by, in order to calculate P,
1,000.
what I will be using?
1,000.
I should be
1,000.
divided by 1,000. So this and this is going to get cancelled. If 2 lakh population is given, then population in 1,000 means it will be 200.
200.
P is 200. Is it clear? Is it clear to you all?
Yes, sir. Yes, sir.
Yes, sir.
Okay. I should move ahead. Shall I go ahead?
Yes, sir.
Next formula is Freeman's formula. So again, to find out the quantity, Q is equal to 1136 into the bracket P divided by 5 plus 10. Okay. Again, P is population in 1,000. Now, again, there is one more formula. This particular formula, we call it as an National Board of Fire Underwriters formula, which is not written in this particular notes. By mistake, it has missed out. So this particular equation, we call it as an National Board of Fire Underwriters formula. Okay, so this will be normally asked. So here, the according to this formula, we the quantity, in order to find out the quantity of water required in case of, according to the National Fire Underwriters formula, the quantity of water required is 4637 square root P into 1 minus 0.01 square root P. So this is what the underwriters formula. In all these, if the problem is going to be asked in these particular area, in this particular area, that is, they are going to ask the question like, compute the fire demand for a city having population of 1,40,000 by using various formulas. Okay, or they may ask you two or three by three methods you determine: Koechling's formula, Buston's formula, or Freeman's formula, or all four they may ask you, right, in the problem. So you need to remember these four equations. You need to remember these four equations when you are going to solve the problems. You first Koechling formula, Buston's formula, Freeman's formula, and the National Fire Board Underwriters formula. All these four formulas you need to remember when the problem is going to be asked in fire demand. And one more thing, what you should remember in this particular problem is population. If they are going to, P is all in all formulas, P is nothing but population in thousand. They may give you 20 lakh, they may give you 50 lakh, they may give you 1 crore. So if you want to convert that in population in thousand, you should divide it by 1000, and accordingly you should use the P value. I hope the things are clear to you.
Yes, sir.
Yes, sir. Yes, sir.
Okay, shall I go ahead?
Yes, sir.
Okay. Now next loss is, right, this is over. Fire is over. Now we will be covering the losses and waste. The next type of water demand is the losses and the wastes. Okay, now whenever there is an breakage in an water, you see that in day-to-day life there might be some of the breakage that may be occurring when there is a cracks in the pipes, or something goes wrong in the pipes, or due to the maintenance, right? There may be sometimes there is a crack, or there is a water loss is going to happen, or might be sometimes the faulty water valves and fittings might be there. At those particular cases, there might be water loss is going to happen at that particular point. So we consider those particular losses as the water losses. We consider this as water losses. Or sometimes some people, what they may do, they may keep the tap open and they may waste the water. So all these will, and sometimes the unauthorized or illegal collection. So all these will be considered under these particular water losses, or water loss due to the illegal connection or some theft, or due to the faulty walls. All these will be considered as a losses. Next is, we will cover the topic called as the per capita demand. I hope the water demands, different types of water demands are clear.
Yes, sir.
Okay. Now, what are the different types of water demands? Different types of water demands. Can anybody tell me?
Domestic, industrial, residential.
Okay.
Domestic,
Public,
industrial, commercial.
Then
Demand for public use, fire, losses and
Fire demand.
very good, very good. So all are attentive. Next. So these are the different types of water demand. Now I will be covering per capita demand. Right? I was telling the word per capita demand. I can pronounce it as LPCD, liters per capita per day. Okay. I can, in a short term, I can call it as an liters per capita per day. Now it is nothing but it is an amount of water required by a person in a day. Okay. For example, if I am consuming around 100 liters of water in a day, that means my water consumption or my per capita water demand is 100 LPCD. That means one person will be consuming 100 liters per capita per day. That is nothing but the per capita demand. Okay. Now per capita demand, how we can calculate is Q divided by P divided into 365. Now what is Q? Q is nothing but the total quantity of water required by the various purposes by a town or by a person in a day. That is nothing but it is the quantity of water required by a person or by a altogether, if we consider a town, right, per year, or the population of a town, that is nothing but per cap Q. Then P divided by 365. Okay, P divided by 365. Now per cap P is nothing but the population of that particular town. Here P is population of that particular, in this formula Q is nothing but the quantity of water required by a town per year, right, per capita demand. In a year, if I want to find out of a town, if I want to find out in a town, if I want to find out per capita demand out of the total town's water requirement, if I want to find out the per capita water demand, then what I will do is I will be using Q is nothing but the total quantity of water required by a town per year. How much quantity of water that town is going to require, right, divided by P is the population of that town divided by 365 into liters per day. If I do this, how much per person in that particular town, how much the per person is going to consume the water, that is nothing but we are going to get how much per capita demand we can calculate out of a town. Is it clear? Is this concept
Yes,
is
sir.
clear? Okay. In a town, I will be repeating it once again. In a town, if I want to calculate the quantity of water required by a person, right, Q is nothing but the quantity of water required by that particular city or a town, right, divided by P is what? The population of that town into 365. Why we are going to 365? Because we want to calculate LPCD, liters per capita per day. So we are going to use this particular formulas. Okay. Now the per capita demand is going to be dependent on various factors like standard of living and the type of commercial places in the town. So all these things, it is going to be related. Okay. Now we will see what are the factors that is going to be important in order to find out the per capita demand. Okay. Factors that is affecting the per capita demand means the factors which may affect per person's per day water consumption, that we are going to see, right? I repeat, what are the different factors that the per person is going to consume, what are the factors it is going to affect, that is nothing but the factors affecting the per capita requirement, the factors which is going to affect per person's per day water consumption, that we are going to study now. Okay. First is the climatic conditions. Okay. What do you, how you can explain this? Can anybody explain? According to the climatic condition, how the water amount of water requirement per person per day is going to vary? Can anybody tell me?
Less rainfall.
Less rainfall. What happened? Less rainfall. Climatic conditions. It is related with climatic conditions. I am asking you how the per person's per day water requirement is going to be affected. In that, we are going to cover the first condition, that is climatic conditions. How the water consumption is going to get varying according to the climatic conditions. Yes, can anybody?
In summer season, people need more water, sir.
Yes, in summer season, people will consume more water. Why? Because they will be having two times bathing, and again drinking huge quantity of water. Lawn sprinkling, they may sprinkle the water for the gardening and all for 2 times in a day, right? And again for coolers, they require huge quantity of water. Then again, all these things occur as the climatic condition is hot. The people will drink more water, more usage of water, right? Due to the different reasons, right? lawn sprinkling, more drinking of water, more bathing, right? All these things will lead to more consumption of water. Is it clear? Is it clear?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, what happens in a rainy season?
Yes, sir.
Rainy season, what will happen during rainy season? More consumption of water will be there or less consumption of water will be there?
Less, sir.
Less consumption.
Less consumption. Okay, as the water is available, right? The as a climatic condition is cold, right? The people will drink less water. They will have less time, less number of bathing, right? And all these things so this is what according to the climatic conditions the water requirement is going to change. And again in your winter season, again water consumption will be less. Size of the community. Okay, now as the huge amount of population, huge amount of water requirement, right? Because more amount of population, more amount of will be the water requirement. Size of the community. Okay, right? So it requires, as the population is more, suppose in a town the population is more, then the water requirement of that particular city will be more. Okay, then next point is living standard of the people. Okay, as I have told, I was telling regarding the living standard of the people. Higher class people will be using the say more huge say veranda, lawn gardening, right? Again 2 times in a day in a bath, and again coolers, right? And again might be they are having a swimming pool, right? All these, and again use of flush latrines. Okay, so all these things will lead to higher the standard of people of living, higher will be the water consumption. Next is industrial and commercial activities. As the quantity of water required in the commercial as compared to the domestic area, right? Probably according if the according to the different industries, might be some if there is a possibility that they may use a huge quantity of water in the industry as compared to the commercial areas. But again it is dependent on the type of industry which they are dealing with. Okay, next is pressure in the distribution system. Now if you are using water, you are having a tap in water. If you are getting sufficient quantity of pressure in your pipeline, then your water consumption will be more or it will be less? Yes, it will be more. The pressure is more easily the water is coming in your taps. If the pressure is less, you need to say, in order to fill one particular jug, in order to fill that, you require, suppose you require say half an hour to stand to fill that particular jug. Then what will happen to your water requirement? Yes, yes, you have not understood my question. Suppose in order to fill one particular jug, right? I think you know jug, right? So hardly it will be of 1 liter or 1.5 liter. If it is requiring around half an hour to fill that particular jug, right? Will be your water consumption in other activities? What will happen to your water consumption? It will reduce or it will increase?
Reduce.
Yes, sir.
It will reduce. Why it will reduce?
The flow of water.
The flow of water is less. So for filling 1 liter, 1.5 liter, it is going to take around 30 minutes. So again, the different activities, you need a different quantity, a huge quantity of water to collect that huge quantity of water. Again, it will require more time. So you don't have the patience. So what will happen? So more the pressure in the distribution system, more will be the water consumption. Less the pressure in the water distribution system, less will be the water consumption. Now, system of sanitation. I have told that the system of a sanitation, say if you are going to use a flush, right, in your houses, the water consumption will be high. If you are going to use bucket, or if you are going to use the jug or mugs and all, your water consumption is going to be less, right? And again, it is dependent on the conservancy system and the water carrying system. If you are going to have the water carriage system, right, you require a huge quantity of water as compared to the conservancy system. What is that conservancy system? What is that water carrier system? You are going to learn in the next semester. Okay. Now, cost of water. If you are going to pay more tax, or if your water is going to be metered, right, you are going to use the water wisely. You don't waste the water, right? If you are going to have the water which is going to be the metered, or if it is going to have if your more tax is implemented on your water consumption, right, what will happen to the water consumption? The water consumption will automatically, it is going to reduce. So what will happen? More the where if it is not properly, if water consumption is not properly monitored by the water meter or by the cells, the water consumption will be more if it is not monitored properly. Then a system of supply. There is one more factor which is going to affect the system of supply. See, in the play, we are going to have two types of water supply system. One is intermittent and one is continuous. What do you mean by intermittent? Intermittent water supply?
Time gap, sir.
Intervals.
Yes. If you are say if you are getting water once in 4 days, that too around for 2 hours, 3 hours a day, that kind of a system of water supply, we call it as the intermittent water supply. If you are going to get 24/7 water supply, we call it as a continuous water supply. If we get the water 24 hours of the day, we call it as a continuous supply. If we are getting 2 hours in a say 4 days or 3 days, or in a single or day to day, if we are getting only for 1 hour, 2 hour, that we call it as an intermittent supply. So what will happen if we are having the continuous supply of water is there, then what will happen? The water consumption is going to increase. If we are getting the intermittent supply, what will happen? The water consumption is going to get reduced. Yes, it is going to get decreased. So these are the factors which is going to affect the per capita consumption. Is it clear?
Yes, sir.
Okay. So in today's class, what all we have discussed? We have discussed what is the water demand, right? What is water demand? What are the different types of water demand? How the per capita consumption per day, how it is going to affect. We have seen some of the formulas on fire demand, and from those formulas we are going to find out, we are going to calculate how much the quantity of water is going to require in case of fire accidents. So in the next class, we will be seeing the population forecasting. In the next class, we will be seeing, or we will be calculating how to find out the population forecasting. Population forecasting is nothing but we are going to predict how the population is going to increase in coming 10 years, 20 years, 30 years, 40 years. That we are going to study. From the next class, probably we may deal with the problems. We may deal with the problems with the fire demand, and we may deal with the theoretical part of the population forecasting. Though we are going to deal with the population forecasting theoretically, we will be learning some of the formulas, right? We are going to learn formulas, how we are going to calculate the population forecasting, which is going to help in determining the population forecasting. So coming classes are very, very important. So all of you need to attend if you want to solve the problems. Okay, all of you have to be attentive in the next coming classes. Okay, is there any doubt?
No, sir. No, sir.
No, sir.
Okay, we will end the session over here.
Yes, sir.
Okay, fine. We will end the session.
Thank you, sir.
Yeah.